Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we're given two massless frictionless pulleys and a canister with the mass 20 kilograms being attached to one of the pulleys, and a force F is being exerted on the free end of the cord of the first pulley. Now, for part A, we need to find the magnitude of the force required to lift the canister at a constant speed. Now, we can do that by considering the tension in the rope. So since the pulleys are massless and frictionless, the tension at every point in the rope must be equal, and let's call it D. So here the tension is opposing the force applied F, and let's call the pulleys A and B. And here we can see the tension will be opposing the weight of the canister in pulley B. So let's call the weight W. So let's consider the forces on pulley B. So the forces on pulley B. So we have T acting upwards and another T acting upwards, and then the weight acting downwards. That gives 2T minus W as the force on B. Now since B is not in motion, then it must be in equilibrium. And if it's in equilibrium, the net force must be 0. So that gives 0 equals 2T minus W, and that gives W equals 2T, and T is equal to W minus 2, and W is nothing but the weight, that is the mass times gravity, rather the gravitational acceleration, divided by 2. Now let's consider the forces on this end. Let's label this point in red. And from here, we can determine that the force F is equal to T, because again, this point is not in motion. So T equals F equals mg divided by 2. The mass we know to be 20 kilograms times 9.8 meters per second squared. That is the acceleration due to gravity. And the entire thing is being divided by 2, and that gives the force F is being equal to 98 newtons. So for the second part, the canister must be raised by 2 centimeters. So the canister must be raised upwards by 2 centimeters. And we need to find the amount by which the loose end must be pulled down. Now, to rise 0.2 centimeters, both of these must be shortened by 2 centimeters as well. Now for that to happen, one end must be pulled, so 2 centimeters upwards, so that will give 2 centimeters downwards for one side. But now this needs to be pulled downwards as well to accommodate, and that means a further of 2 centimeters needs to be pulled. So the total distance, let's call it D, that needs to be traveled to raise the canister by 2 centimeters is 4 centimeters, which is basically the sum that the individual ropes need to be pulled. For the third part, we need to calculate the work done by the force. So that is simply W equals Ft, since the force is constant. The force we calculated to be 98 newtons, and the distance d we calculated to be 4 centimeters, so that's 4 into 10 to the negative 2 meters. The 10 to the negative 2 meters is just the prefix centi, and we get 3.9 joules as our answer corrected to significant figures for the work done by the force. Now for the last part, we need to find the change in gravitational potential energy. That is given by the formula E equals mgh, or we can simply find the force find the work done by the gravitational force in traveling a height h. Now, gravitational force is simply mg, and h is the change in height, so these expressions are equivalent. So our mass is 20 kilograms, acceleration due to gravity 9.8 meters per second squared, and the change in height was 2 centimeters, so that's 2 into 10 to the negative 2 meters, and multiplication of all of these will result in 3.9 joules, which is the same as the answer calculated in the previous part, so our answer is consistent.